because it was bugging the heck out of me. I went back and with minor tweaks, I did it with an x cubed. I'm going to leave this here for a few seconds. And so if you're interested in it, you can go back to the video and just pause on this and you can write down the working, because I don't want you to start writing frantically because it's not going to be here long enough for you to do that. But essentially the one that I screwed up multiple times, because I did it with an x squared and it didn't work, and I did it with an x to the 4, it didn't work. But if you do it with an x cubed, it does work. Actually, it's a pretty ugly answer, but it works. So let's show you what we're doing today. I want to do 3 more questions. I've reduced the homework. I think it's down to 10 questions or something like that. So you're going to have, you're still going to have a lot of time. It'll take you a while to do them. I think I'm averaging about 15 minutes a question now. So you kind of figure out you get 4 an hour. So bear that in mind. Don't wait too late to start doing them. So we're going to do these 3 questions. That's the first part of today. And then after that, whatever time we've got left, I'll talk a little bit about your test, which is coming on Monday. So if you see an integral with a number, take away x squared, you're going to use a sine theta. If it's x squared, take away a number, you're going to use a secant theta. And if it's x squared plus a number or number plus x squared, they're equivalent, you're going to use a tan theta. And this is a version equation 7. This is a version equation 8. And this is a version equation 6. And I chose them because they do the same, you know, basically one of each of these. So you get to see every single one one more time. So let's start with our first one. There is a shopping list of how you do that, or maybe a list of ingredients would be another analogy. So you do this first, then this, all the way to the end. Now, for instance, in this question here, the first thing you're going to do is you're going to make sure that you choose the correct x sub. And this is a number take away x squared, so you are going to do 7 sine theta. Now, in some homework questions, they tell you who that is, which is great. In some questions, they don't. So you got to know how to figure it out. Now, what I'm going to do now is differentiate with respect to theta. And that's going to get me 7 cosine theta. And then I'll do my crossover. And I have 7 cosine theta d theta. And at that point, we're finished. And then I take this guy. And the next stage is to turn your integral into thetas. So x squared is going to be that guy squared. And I'm going to call him sine squared, sine squared. Right, 7 squared, sine squared. On the bottom, I'm going to have the square root of 49 and take away that guy squared, and I'm going to call him 49 sine squared. Times 7 cosine theta d theta. Now, it's quite common in these questions that there's a square root, and it's also pretty much guaranteed that this becomes a lot simpler than it is. But right now, if you combine the tops, you get 7 cubed sine squared theta cosine theta. Okay, let's see if we can do this in one go. Would you agree this is 49 brackets 1 minus sine squared? Right, if you pull a 49 out as a common factor, 49, 1 minus sine squared. What is 1 minus sine squared? 1 take away sine squared.
Cosine squared.
And so that bottom thing becomes 49 cos squared. And now we have 7 cubed sine squared cosine theta over 7 cosine theta d theta. And some of you who are braver than I am, can't you go from here to here? Now, a little tidying up. Cosines kill each other off. One of the sines cancels and you've got, what do you have? 49. So I'll pull it outside. And the integral that we have left looks like that guy. Now you're going to end up with an integral with sines and cosines in this particular question, and that's kind of guaranteed. What you're going to have to figure out is what technique that you're going to use to integrate it. You're either going to do a u sub, and if it's a u sub, fine, it'll be u sine theta or u cosine theta. If that's not going to work, because sometimes it doesn't, aren't you going to have to look for a trig identity and turn this into something else? Would you agree this is going to be one of those situations? And would you also agree it's going to be that one up here? So you've seen this before and you'll probably see it again. We're looking at that guy, right? I bring the 2 outside. That way, I only really need to focus on this and then remember to multiply by an ugly guy. So what we're going to get here is a theta. If you integrate a cosine, you get a sine. So if you integrate a cosine 2 theta, you get a sine of 2 theta, and you also get a half. And so this fella, the original integral, which was this one, has been integrated, and it ends up being 49 halves theta, take away 49 quarters, the sine of 2 theta, add C. So far, so good, right? And now we have to figure out what to do next. Well, what to do next is we need to get the answer back into x's. And the way that we do that is that we return to the x sub that we used. And we rewrite it so that the sine of theta is on its own. And then we use SOHCAHTOA. And the sine is opposite over hypotenuse. And from this, we create a very special right angle triangle. And in this triangle, we'll make this angle theta, which makes the 3 sides opposite, adjacent, and hypotenuse. And the top guy is opposite, so that's x, and the hypotenuse is 7. And how do I find the adjacent? How do I find this guy?
Use cosine.
Well, if I had one, I would certainly use it, but since I don't, I won't be able to do that.
Oh, I mean, you get the adjacent over the hypotenuse.
Yes, but that would be the cosine. So don't go there. Think of something else instead.
The square root of the hypotenuse squared minus opposite, so 49 minus x squared.
Right. So Pythagoras is the guy, which might be what you were trying to get at when you said opposite and hypotenuse, but didn't come across that way. And isn't there a good sign that that's the right one? Do you see it there in the integral? If you don't see your triangle with that guy, you should be worried because it should be there. Well, let's continue the process then. From this triangle, we can use it to find these guys. Well, let's look at the sine of 2 theta. I'm going to use the fact that it's 2 sine theta cosine theta. So it's going to be 2 times. The sine is this ugly square root over 7. And the cosine is just x. Cosine, sorry. I got them in the back to front, but anyway, that's the sine and this is the cosine. So I kind of got lucky. This is what the sine of 2 theta is. Now, if I needed to know what the cosine was, it's this square root over that. If I need to know the sine, it's this. If I needed to know the tan, it would be x over this. If I needed to know secants or cosecants, couldn't I just turn them upside down? Any of the 6 guys can come from this triangle. So you're good. Now, the next guy we've got is theta. And what I'm going to do is a little trick. Put it in this box here. If x over 7 is sine theta, then the inverse sine of x over 7 is theta. So now I know theta. So we've got all the pieces and we're finished. The integral that we started with is 49 over 2 theta, which now becomes the inverse sine of x over 7. Take away 49 quarters of this. So take away 49 quarters of this guy. A little cancelling going on here. So our final answer, once it's been simplified, they cancel, they partially cancel, ends up being we are done. That's the first one of the 3 done, and it took me, 15 minutes. So 2 pagers, right? It takes 2 pages to do it. And that's the first one. Any questions about that one before I move on? Are we good? Okay, let's move on then. The next one in my list was similar to question 8. It's going to be the integral of that guy over that guy dx. And the x sub was 6 secant theta. So differentiate x with respect to theta. If you differentiate 6 secant, you get 6 secant tan. You do the crossover, then you get 6 secant tan d theta. That's the substitution part done. You go over here. And you replace all the x's with 6 secant thetas and the dx with this. So it's going to be the square root of this guy squared. So that's 36 secant squareds. Take away 36. And you're going to have this guy to the power of 4. So I'm just going to call it 6 to the power of 4 secant to the power of 4. And then all of this stuff. 6 secant tan d theta. No, I had to squeeze it in, but got what I got. Right. This guy's 6 secant tangent d theta, right? That's what that guy is. Okay, at the bottom, I'll just leave for a few seconds more. Okay, the square root guy, he's going to come out nice. You can pull out 36 as a common factor, agreed? And won't that leave you with secant squared minus 1? What is a secant squared minus 1?
10 squared.
And so won't this be the square root of 36 tan squared? Are you all happy about how that became this? Now you can take the square root of this guy and get 6, and the square root of the tan squared and get tan. I got this fella still, and I've got all this stuff as well. What can we do? That and that cancel out 2 of them, so that leaves me with 136. That secant partially cancels that guy out, and so I'm left with tan squared on the top, and it looks like a secant cubed on the bottom, d theta. Okay, am I good? Any obvious mistakes? I'm not saying I've got one, but tell me if you see one. Look good? Let's proceed then. At this point here, don't you have to integrate this thing? And it's a U sub, or it's do some trig identity and change it in some way that allows us to solve it. It kind of looks like it should be a U sub, doesn't it? Because it's got tans and secants in it. And if this had been tan squared times secant cubed, right? If it had been that, I definitely would have thought seriously about a U sub, but it's not. If you try secant theta, will you trust me, it goes nowhere. And if you try tan theta, it's just equally as bad. Now you might say, well, how do you know it goes nowhere? If you do a U sub, as long as it's secant squareds and tan squareds that are left over, right? There's a bit left over typically. As long as it's secant squared or tan squared, you're okay. You can get out of the hole because you can do one of these. But if you ever get a secant left over on its own, or a tangent left over on its own, then you're in trouble. So that's how you know it's not working. So any suggestions about how to rewrite this in a different form that might work?
Put it all in terms of sines and cosines.
Right. Isn't that a kind of backup plan when all else fails, right? And that's the right thing to do here. So tan squared is going to be sine squared over cos squared, right? And secant cubed is going to be 1 over cosine theta cubed. That doesn't look too promising, but it is good. It's the same thing as the top fraction, right? The tan squared guy, this guy, times the reciprocal of the bottom guy, d theta. Are you okay with dividing by 1 over cos cubed is the same thing as multiplying by cos cubed? You're comfortable with the algebra, right? This is essentially top guy divided by bottom guy. Top guy times reciprocal of bottom guy. And if you want to see it as a reciprocal, how about that? Now, there's a little bit of cancelling going on. Now, would you agree that's a much nicer integral to deal with? And this one does work with a U sub. And it has to be sine theta on its own or cosine theta on its own. And that's the choice. You just don't have any others. Which is it going to be? What's the U sub here?
Sine theta.
Correct. What was your reasoning behind why you picked that one?
Because once you do the U sub, you'd be left with only U's. But if you used cosine as the U sub, then you'd have a sine theta left.
Right. Sounds good to me. So cosine theta and crossover. And then divide both sides by cosine. To get d theta. So we have 1 over 36 u squared cosine theta 1 over the cosine of theta du. Oh, is that not a pretty integral? Just a u squared. Power rule. Return back to the thetas, right? And we're at this point. So far, so good. Now, is it the last stage to take the integral, which will be in thetas, and return it back to x's? So I know that x is 6 secant theta. We used it here. So x over 6 is secant theta. Right. A cosine is adjacent over hypotenuse. So won't a secant be the opposite of that, which is hypotenuse over adjacent? You okay with me switching the order? Right, turning upside down. So I can build my little triangle. I have to be a little baby one this time because I've not really got a lot of live room. There's my opposite. There's my adjacent. Here's my hypotenuse. And what do I have? Hypotenuse is x. The adjacent is 6. And if you use Pythagoras, you get x squared take away 36. And quick check, perfect. What I was hoping to see. And in this question, I really only need to find out what sine theta is. And sine theta is opposite over hypotenuse. And so the answer, which is this one here, is 1 over 108, this guy cubed. Now, if you cube this guy, you're going to get the square root of x squared take away 36 cubed, all over x cubed, plus a c. And we are finished. And I did that one in 11 minutes, which is faster than I thought I was going to do.
Can I ask a style points question?
Sure.
Oh, wait. Would you maybe separate the x squared minus 36 and take out one of the factors? So it was like x squared minus 36 times the square root of x squared minus 36. Would that be better style points or worse?
Neither. It would be just as good.
Okay.
In other words, I'm happy with both.
Okay, cool. Thank you.
Right. And if I pick you up right, that's what you were thinking. Agreed?
Yeah, that's what I was
Yeah,
thinking.
nothing wrong with that. I don't know what WebAssign will take. I'm always worried when I do questions that we do them right, but then WebAssign isn't, because I could imagine, I'm just saying this, don't quote me because I could be wrong, that WebAssign might write the thing down like this. Agreed? I mean, that is equivalent. I do not like that for style point reasons, right? I mean, if the original was x squared minus 36 in brackets to the power of half, that's actually the way I would have went with my answer, right? But it wasn't. So this and this are fine. Good question, though. Never thought about other ways of writing it that are just as good. Slightly out of order, numerically at least, our last one. X cubed, the square root of 1 plus x squared. And this one, it's technically 1 times tan theta, but that's really just tan theta, isn't it? Because it's almost the square root of that number. So if you differentiate a tangent with respect to theta, you get secant square theta. And if you do the crossover, you get secant square theta d theta. Now, the more of these darn questions you do, I hope you will begin to see. Someone has just said the only way that you can get your answers on Weber sign is to do the fractional one that I gave a few minutes ago. You know, the one where I said 3/2. I don't know if that's your experience as well. You know, Weber sign is software, it's not human, so it's not always as good as it could be. So bear that in mind. You might have to call the thing to the 3 halves. Right, back to this fella. X cubed essentially is tan cubed. Square root of 1 plus tan squared theta. And instead of the dx, we got a secant, and we got a d theta. Okay, what's 1 plus tan squared? We should be getting used to this now. What's 1 plus tan squared going to end up?
Secant square.
Secant squared. So we're going to have that guy. Square root of secant squared. Secant cubed. D theta. And that's a secant. So what you are now looking at is that guy. I'm going to change color.
Professor,
Yes,
I'm not sure if, is that a secant square and you turned it to secant cube?
that's a square. Now it's a cube. So it's still secant squared, then this one gets joined to its secant cubed.
Okay, thanks.
Let me check that. Yeah, it's a secant squared, and this gives you another secant. I kind of did it in my head when I did it one step early, but thankfully this answer is correct. Okay, you got a problem. You got secants and tans. If it's going to be a U sub, isn't it secant theta or tan theta? And if those don't work, aren't we going to do the turn everybody into sines and cosines trick, as we did in a previous question? So let me tell you right now, it is a U sub. So one of the 2 U subs work. Now the challenge is which one is the right one? Secant theta or tan theta?
Secant theta.
You're 2 for 2 today, Mia. Why secant? That's the right answer.
Because once you find the derivative, it's secant theta, tan theta, and so then those cross out, and then you get tan squared theta and secant squared theta, which is good for when we do the antiderivative and all that.
Right. So, I'm putting words in Mia. Get this right. I'm putting words in Mia's mouth. She's virtually doing that question in her head. At least when I do it, I can actually visualize what would be written, and so you can kind of see it. And she sees that if you do that one, all you're going to be left with is tan squared and secant squared. And we know aren't tan squares and secant squares okay? As long as that's all that's left, you know it's going to work. If there's something weird left over, like a secant somewhere, then you don't go there. Trust me, if you did tan theta as your U sub, you could do that. You're going to have a secant theta left over you can't get rid of. So I would know why that was the wrong one. But this one works, so let's use it. If you differentiate with respect to theta, you get secant tangent. Now you get secant tangent d theta, and then you divide everybody to isolate the d theta. So secant tan on the bottom, du is d theta. When I do questions with sines and cosines, I turn them into u's. When I get things with secants and tans, I leave them alone for a little while. So this is just going to be left alone as tan cubed, secant cubed. And all I'm going to add is replace the d theta with 1 over secant tan and du. And now I get a bit of cancelling.
Hey, Professor, I have a question.
Yes, what's the question?
The tan cube and the secant cube, we chose u to be the secant
Correct.
theta, right? But how do we know which one it's going to be the u? Because I see that tan cube theta could also be, if you were to factor that out, it would be tan square tan, and then if you were to get another expression for it, it would be -1 plus secant square.
If you use tan theta, it doesn't work. Now, what you said, I think you might have missed a term, and that's why you didn't realize that it didn't work. As soon as I finish getting this pretty, I'll go back to that question and try it with a tan just to show you why it doesn't work, right? Because sometimes you have to see all the steps to keep track of it. But in this case, U is secant, so I can do that. What about tan squared? How can I take tan squared and use it in terms of secant? What will tan squared get you in terms of secant? What will tan squared get you? Anybody?
Secant squared minus 1.
Okay, agreed. And isn't secant squared minus 1 just that? And that becomes u to the 4 take away u squared. And the power rule gives me this guy and this guy. And then I've just got enough room to squeeze it in. 1/5 that guy, take away 1/3 that guy, plus c. So would you agree that this u sub worked, right? We got an answer in terms of theta. So let's just keep that guy there and pretend that we were trying this question out a second time. Oops, try again. This line I should be looking at. Only this time, I'm going to do tan theta. Okay. Now, if you differentiate tan theta, you get secant square theta. And then you do your crossover, you get secant square theta d theta, and then you divide. Nothing too dangerous has happened yet. And leave the first two terms alone. So leave it as a tan cubed, secant cubed. Turn the d theta into 1 over secant squared theta du. They cancel, and you are left with tan cubed theta, a single secant theta du. Now tan is easy because tan is u. There's your problem. An orphaned secant theta. Now, secant square theta is fine. Do you know if it's a secant square theta when I just used one of my identities over here and I would turn it into 1 plus tan squared, then we'd be great, right? So when you're doing the secants or the secant tan combination, or for that matter, the sine cosine combination, don't you not want an orphan left over, right? You don't want to pick a u sub and say, oh, I've got a sine x or a sine theta, whatever it is, and I can't get rid of it, right? I can't turn it in terms of the other variable. Sine squared, cos squared are fine. Tan squared, secant squared are fine. But that guy is the problem, right? You can't do anything with them. Now you could, I guess you could say, well, can't I call it the square root of 1 minus tan squared? Yeah, you could, but then you'd end up with an integral that ends up being just as bad as the one you started with. And so you go back to square one and you're no better off. So you can't do it. Hopefully that kind of explains it. Right? So we got this horrible guy to deal with. We want to turn him into x's. So I'm going to go back to the beginning, the x sub, and I'm going to think of it as x over 1. which means that we have an opposite over an adjacent. And so I can build my triangle. There's my angle, my opposite, the adjacent, and the hypotenuse. The opposite is x, the adjacent is 1, and by Pythagoras, you get that guy, which is perfect. And in this story, I need to know what a secant is. So secant theta is the reciprocal of a cosine. So instead of adjacent over hypotenuse, you use the other way around. Hypotenuse over adjacent. And hypotenuse is this ugly guy, and adjacent is 1. Oh, well, then that's just this ugly guy. So now we know what our answer is. The original, which was this guy, is 1/5 secant to the power of 5. Take away 1/3 secant cubed. And that's us done. I don't think with any stretch of the imagination that these questions are easy, agree? I mean, there's lots of places that you have to sometimes, figure out how you're going to get over this hurdle, right? Am I going to do a U sub? Am I going to have to, which U sub if I am? Which X sub? Or what trig identity am I going to use to get out of this hole that I'm stuck in? But at least it has a process, doesn't it? It has like a 1, 2, 3, 4, 5. And if you go back and you look at yesterday's, with the exception of the last one, which still bugs me, right? But if you go back yesterday and look at the 2 that did work, and today the 3 that did work, haven't we got a body of experience now that we can use when you come to do your own versions? And so, who knows what's going to happen? I haven't done every single homework question. I do know that the process works, but sometimes you have to figure ways around it. Remember we did an integral with sine squared. Wasn't that a trig identity that got us out of that one? Didn't we do one with tans and secants where we had to turn everybody into sines and cosines to get out of that one? Didn't we get a much more straightforward one where the U sub worked and the X sub worked and everybody was happy? You have to just, look at what you've got and then, play with the hand that, you've been given. See if you can make 4 aces out of it. There's 4 aces. Let's talk about your test, which is, as you know, coming up. It'll be on Monday. It will be pretty much the same as before. You will turn up 10 minutes early is fine. It will appear on Canvas as a PDF. You'll do it on paper and you'll scan it and send it to me. I think what I should do now is talk about what is in it so that we are in the same spot. Let me stop sharing. Come on, you can do it. Stop sharing. There you go. Okay, so we are looking at these sections here. They're going to be 1, 2, 3, 5 questions. Just checking the number. Your first question is going to be volumes using cylindrical shells. Remember the 2 pi x f of x type of question, right? Volumes of revolution, 2 pi x f of x, that one. You're going to get a question on work. It might be about springs, or it might be about pulling buckets up cliffs with leaky holes in them. Remember those guys? Right. Average value of the function is probably going to be the most obvious and straightforward question. Isn't it just a formula and plug and chuck? Right, 1 over b minus a, do your thing. Integration by parts, right? You're going to get a question from there. I may give you one of those questions where I don't ask you to do it, but I give you the question and I say, who is f of x and who is g of x. You know, the one where I asked you to pick. A bit like the u sub question. I might do that as part of it as well. I may not. Haven't written it yet. And then your last question is actually 7.2 and 7.3 together. So you're going to get one of the questions we did today, or very similar to it. In that question, didn't you have to do trig u subs and stuff anyway? So I'm testing the u sub stuff from 7.2 while I'm testing 7.3. Now, those questions take typically 15 to 20 minutes, and I understand that, but they'll be worth more points because of that. But at the other end, won't an average value of a function not take you more than 5 minutes, right? So you still should have time to do the 5 questions. But the last question is going to be the stinker, right? It's going to be a lot of points and it's going to be hard. But remember, if the process is correct, even if a square turns into a cube accidentally, I'll be pretty generous about it as long as you go through the process correctly. You won't lose much. So think process rather than answer. So don't tell me the answer's 42 or sine cubed or something, because I'm giving you nothing. You know, if I don't see working, it ain't happening. I mean, you could just go online and type it in and, you know, get an answer from somewhere. Any questions? You ready for this test? Will you be ready on Monday then? Yes, okay.
We'd be prepping more pulling chains, pulling buckets of coal, or more like springs and things?
I ain't telling you. You'll find out on the day. You
Okay, fair enough.
you won't get both, but you'll get one. Right. You want springs because they're easy, and you might not want buckets because they're hard, but that doesn't mean that you will or won't get either of those two.
What time will the test be?
For you, you can be here at when do we start? So I'll making it visible at 10:50. So make sure if you're going to be here, turn up at 10:50 so I can see that you're here, and you know the usual. Make sure you're not cheating, which I know you wouldn't, but let's just make sure I can verify that. And try to think of anything else that I haven't covered. Do you want a joke?